Welcome, Geometry. This is Camelot, Math Education in Mrs. Brucaleri's classroom. Do you have everything you need about you? You need to. So we're going to review starting with the worksheet you got on Friday. And here is the worksheet we got on Friday. So I'm just going to give you a few reminders before we proceed on this. You have your homework log, your hard copy. That is this homework log. You know what that looks like. You know where we are. You know what you've done. You know what you haven't done. So you should definitely, last week should be done before Friday of this week. You've had plenty of time off. If you're confused about what's going on, you need to go back and rewatch that wonderful warm up, get your stuff together, start getting organized, and we're going to hit it as normally we would on Monday. So be aware and be prepared with paper and pencil and highlighters and color and all that good stuff. So I'm here alone in my classroom. So as you may have noticed, I have King Pellinor to talk to and point out my errors and my 50 lashes with a wet noodle, although I don't think King Pellinor will do that. King Pellinor, would you come here and introduce yourself? Oh, good lady. Thank you. I would never give you lashes. I appreciate you inviting me into the classroom, and I'm here to help and keep you, Mrs. Brooke, on task. Oh, thank you, King Pellinor. Okay, I'm going to push you out because I need to work on this paper. No problem, dear lady. I'm here. I have your back, and I will help you keep on track. All right, so we're starting with this worksheet. You've already done it. It's due, and we're looking at answer keys. So reading the directions, it's in front of you. So reading yours as I look at mine, you are just supposed to count up. Idea of counting, how many? So vertices, edges, and faces. So there's 6 vertices, 10 edges, and 6 faces. And on the second problem, there are 8 vertices, 12 edges, and 6 faces. Don't forget, this is a video. This is not live. I will do my first live thing with you guys on Friday. So be aware, that's tomorrow. And it's during a given time slot. So if you want to be here and ask questions, you better get after it and be prepared. This is being recorded. All right, and then looking through using our fave formula. So we talked about that last week. I have to go back and look. Polyhedron, that means 3 dimensions. So I have to add 2 to my fave formula. So fave plus 2. Put in your plus sign, put in your equal sign. So faces and vertices equal edges plus 2. So this is going to be 6 faces, 10 faces, 21 edges, 12 edges, and 10 edges. It's called arithmetic. Check your math. There are your answers. If my hands and my mouth don't agree, you know how to amend that or chat with somebody else. All right, using Euler's formula again for the polyhedron below, and then drawing a net. So remember to draw a net. It's best to have another sheet of paper, drawing to dimensions, so I can see that this is a pentagon, and this looks like a trapezoid to me. So using my geometer, I can nicely create the illusion of 3 dimensions, although my pentagon is quite large. And so here it looks best when I do it lying on its side, because then when I connect the leading edges, it doesn't look so distorted. So here is my pentagon, and you can see connecting corresponding, and then dashing the other ones to create the illusion of 3D, to create the illusion of 3D. Don't be lazy. You're at home. There's no one to distract you, to bother you, to sass you. Color in those bases because it's all about surface area. So the back side, you know that surface area is going to be the perimeter times h plus the two bases on these prism things. So you are remembering to draw this so you can figure out how that's a polygon. I would have to do my area is 1/2 apothem perimeter kind of thing if I were actually finding the area on this. So draw the things you need to draw. It's important. All right, so with that information, back to here, you drew your pentagon and you drew your net. So then, oh, bad girl, I didn't draw a net. 50 lashes. King Pellinor. Yes, dear lady. This is a polyhedron, not a net. You're supposed to help me, dear lady. I was looking out the window at that hawk. Okay, let me try it again. So, Gemini Christmas. It would be this. You would draw your net, and it has 5 sides, so you know there's 5 rectangles coming off of it. 1, 2, 3. It's got like a flower here. 4. Uh-oh, did I do a hexagon? Oh, God. This is n equals 6. This is n equals 5. How many sides? 5. This is a net. No, not a finish. This would be a hexagon, but you're getting the idea. And then I would have to trap the other base right on top of that. So I got to finish it with the hexa. So there's got to be 2 bases. There they are. So now there's a net of a hexa, but you would do the same thing with a pentagon. So you drew those, and maybe they look something like these 2. And then you counted them up as you did previously. So pentagon, and then here's the trapezoid. All right, and then actually counting those values, you recognize, again, how am I going to do this? There are 7 faces, there are 15 edges, and there are 10 vertices on the polyhedron. There are going to be a different count on the net. And then here on the trapezoid polyhedron, there are 6 faces and 12 edges and 8 vertices. And all those numbers are different on the net. The net, there's more count, more values because every side gets split. So if you want to practice one because you didn't get it on the net when it comes to faces, there are still 6 faces, but now there's 19 edges and 14 vertices. And the net formula is the fave plus 1. All right, and then the last part of this worksheet that you did already, or maybe you didn't, and you're pausing. Oh, stop. King Pellinor. Yes, dear lady. We're doing this on a video. We didn't have videos back in your day. But the idea is they can pause, stop, and take notes and use their color, and they can rewind. Lady, to rewind? What does that mean? They can just scroll down at the bottom, I guess, somehow, and go back in time. Go back in time, like Merlin. Well, Merlin is, some people think Merlin backwards in time, but no, not like Merlin. This is just on their desktop computer. But I'll explain that later, Pellinor. Thank you, dear lady. All right, so go in here in my cross sections, describe it. This is definitely a circle. That is a circle, and there's many little circles down here. So drawing a circle is a cross section. Here, you can see that that plane, like this plane, is parallel to this. And this is, so that is what it is. That hexagon is the actual cross section if I just took this parallel plane and sliced it right here. So again, the hexagon is the cross section. Now this one is slanted, so it's causing a distort. This is parallel, so there's a distortion here. So you want to actually connect along here and connect parallel lines. These are already parallel. So that is the cross section. And it turns out to be a parallelogram. It is a parallelogram. Parallelogram. All right, so there is side one. Pause it if you need to look again. I can't make the videos too long or it takes 4 hours to upload, and that is not feasible. Okie dokie, so side two of the worksheet, we're looking at surface area and you're reading. So surface area formula, if you didn't write it down, is perimeter times height. It's all about the base, no treble. And so then that's plus 2 bases. That's for prisms. So here again, highlight your bases. Don't forget that. Use your color. The parallel sides in this case look to be like some sort of a quadrilateral. And here there's a right triangle. So it's all about the base. So the base here, 4 by 4, is a square. And so you know that that's going to be a side squared, or 4 times 4 is 16. The perimeters is 4 sides, which is going to be 16. And the height is 10. And now you put those numbers into the formula. So this answer is 192 feet squared. Here, my triangle. My base is a triangle. And it is going to be 1/2, and the perpendicular numbers. Oh, Pelinor, I know you studied Pythagoras, or Merlin did. Yes, dear lady. Merlin and Arthur worked often with Pythagoras' theorems. So this triangle is a right triangle. Okay, dear lady. So we have one leg is 4. We have one leg. No, that's not a leg. A hypotenuse is 5. What's the other leg? Dear lady, the most famous right triangle, consecutive numbers, 3, 4, 5. Yes, it's a 3, 4, 5 triangle. So it's 1/2 3 times 4, which is 6. So there's my area. Big B means area. Thank you, Pelinor. My pleasure, dear lady. All right, so perimeter is 12 feet, and the height is 6 feet. So when you do all that on your own, you're going to get 84 feet squared. This is the one you were asking me about in class, the one I just drew, the pentagon. Yay! So the pentagon figure that we drew earlier here, that's the pentagon on its side. That's the pentagon standing up. So using that very same information. So when I look at this pentagon and I just ascribe that information to the same thing. So I'm taking this, let's see, make sure I'm on this pentagon right here and this shape here. Let's putting them together. So this is going to be H is 11 and my side is going to be 5. So I'm doing this problem right here on a sheet of paper. Pause the video, get your sheet of paper. And so when I do the lateral area, it's all those rectangles, but the shortcut is PH. And so we know our lateral area is the perimeter, and the perimeter is going around, and we have 5 5s. So that's 25, and the height is 11. So there's your lateral area. So when you look at big B, my value for big B is given. That's part 3C. So big B, if you read, big B is equal to 43. So now you have PH and you have big B. So when you go back and do the arithmetic on those parts, you're going to get 275 centimeters squared for the lateral area. You're going to get 860 for the total sum meters squared. Meters or centimeters? Oh, this should be centimeter. They're both centimeters. And then find the surface area of the prism, and that's 361 centimeters squared. So the bases, the lateral area, the area of each base is 43. Find the sum of all that, and then find the surface area. So those are the 3 different parts there. And then our cube is easy. So we know our lateral area is going to be the 4 rectangles, whichever 4 you choose. lateral area, these are the big B's. That's different. That doesn't include. That's without the base. The lateral area was without 2B. So that's going to be 196, and then the surface area will be 294 meters squared, including the yellow bases. Here, very similar to problem number 2 above. This is like number 2. We have our lateral area is going to be 132 centimeters squared, and that's just the triangles. And then, oh no, excuse me, that's just the rectangles. And then we add the triangles. So surface area is adding the 2 triangles. Again, 3, 4, 5 triangles. And that's going to be a total of 144 meters squared. Now, cylinders are different. The lateral area is actually that rectangle that's from Mr. Quaker Oats, and we know that's 2 pi RH, so pay attention. So it says to find lateral area because you read. So here the lateral area is going to be 40 pi meters squared, putting that R is given. R is given, and so my lateral area is going to be 308 pi meters squared. And then here you are reading a box of cereal we recognize is a prism, a polyhedron. And so it tells you that the dimensions 11 inches high, 2 inches deep. If all surfaces are made of cardboard and the total amount of the overlapping cardboard where they glue it together is 6, how much cardboard, 7, how much cardboard is used to make the box? So we're going to have to take all of this surface area plus the 7 for the overlap. So that's going to be calculating your prism formula is 252 plus the 7. So there is my surface area. We already know that formula. And so your total is going to be 259 inches squared. So read. Without me, you really need to read 3 times. The overlapping was given as a 7 where they glued it together, and the surface area formula is there. All right, and then we have this last problem here. Looks like some sort of a mailbox or lunch pail or backpack laying on its side. So we know when we read this, judging by appearances, what is the surface area of the solid? So when I look at this, I see this end. That's going to be half of a cylinder plus the rectangular prism. So you're going to have to take half of the cylinder formula. So half of the cylinder is going to be that formula from your notes. This is not math magic, is 2 pi RH plus 2 pi R squared. That's the cylinder formula. And then you're going to have to add the rectangles, the perimeter times H. And here's your danger, Will Robinson. Pelinor, I promise I will introduce you to the robot. I don't have Will Robinson. Dear lady, I am looking forward to meeting the robot. Or what? A robot. Yes, thank you. Thank you, Pelinor. So it is the lateral area going all the way around, but you notice this space is missing. So when I go add the bases, I'm going to add 1 base because the other base is missing. And if you do that correctly, you do the math, it's 1082 centimeters squared. So pay attention, 1082 centimeters squared. And that is our first video, kind of like a lesson, a review. So it's not a lesson, it was a review. We're paying attention here. You pause and rewind. If you didn't hear what I said, go over it again. Did I probably make mistakes? I am not used to being on the video, so I'm sure that I made mistakes. So I just want you to recognize, you pause, figure it out, and you can ask me on a live session. And I think the first one will be Friday. So there it is, your first session. You are going to keep notes, keep color, keep your geometer handy. Welcome to Camelot. You're doing your work.